honored guests. Welcome to this momentous occasion. 23rd Inaugural Lecture of the University of Moratuwa. The journey of introducing esteemed professors to the public and today marks the 23rd milestone. So, it's my great pleasure to invite Senior Professor Lankan to introduce today's distinguished professor.
Good afternoon, Professor Gopura, the Faculty of Graduate Studies, Prof. Abeysinghe, ladies and gentlemen. It's really an honor to present the distinguished career and remarkable research journey of Professor Abeysinghe. Professor Abeysinghe graduated in 1993 with a BSc Honours First Class degree in Geology from the University of Abeysinghe. Soon after, he got a scholarship in 1994 to do engineering geology master's studies at AIT Lankan. And then in 1996, he joined the National Building Research Organization in Bandara as an engineering geologist, working there for 3 years. In 2000, he was awarded Membership Scholarship to study the PhD at Sada University, again in engineering geology. Dr. Abeysinghe joined the Department of Earth Resources Engineering, University of Moratuwa in 2004. He's a founder member and a former treasurer of Institute Geology of Sri Lanka and a chartered geologist. He served as a head of the department from Department of Earth Resource Engineering from April 2013 to March 2016. He has conducted lectures and research in geology in both Department of Earth Resource Engineering and Department of Civil Engineering. He is a co-lecturer in charge of geology laboratory. Professor Abeysinghe has carried out research in many areas, especially in landslides and mineral exploration. He is particularly interested about rare earth metals. In 2019, a team of researchers, including Prof. Abeysinghe, won a head and DOR grant. This grant allowed him to install ICPMS at the department, and that research was completed very recently. And the project resulted of 5 Q1 research articles and 5 Q2 articles under his guidance. Over to you, Prof. Abeysinghe.
Thank you, Prof. Lankan. Good afternoon for all the Faculty of Graduate Studies and the Professor Ratnayaka. Then I will start with my inaugural lecture. The topic is a new dimension of Sri Lankan mineral industry with critical metals, including rare earth elements. In my presentation is going on. Firstly, we are going with the introduction part about economic minerals and mineral deposits. Then go with the economic mineral deposit and mineral industry of Sri Lanka and critical metals and rare earth elements. And then with critical metals and rare earth element, a new dimension for the exploration and extraction of rare earth in Sri Lanka. Firstly, if you are going with the what are the mineral industry? In the country, mineral industry is based on the economical mineral-based industries. Then we want to know about what are the minerals with economic value. These are known as economic mineral. Then the economic minerals are mineralization and present as a deposit, we know as economic mineral deposit. They are present in or at earth crust. If we call mineral deposits are geological bodies, they can mine to recover minerals or metals. Then if you are going to the metals, we use the term ore. Ore is used for the metal deposit. Yields single or several metals. However, during the mining and then some worthless materials are together with these important minerals or metal, we are removing out, they are known as gauge minerals. Right. Firstly, we think about formation of mineral deposits. how they are formation. Normally, we know about the rocks are formed with three geological processes. We know as igneous or magmatic, then sedimentary rocks and metamorphic rocks. Similar way, mineral deposits also form. The difference is not like rocks, they are concentrated. They are concentrated in several places. Then we have some economic value. As an example, if we see the rocks are present with number of minerals together, but it is small amount. There are no any economical value. However, during this mineralization process, they are concentrated. Then they have a value of as a mineral deposit. Then if you are going with the igneous or magmatic mineralization, then solidification of magma and form a crystallization. Then during this process, magma is approached to the surface. During that, temperature and pressure is drops. This does disturb the equilibrium between various constitution of magma. As a result, they begin differentiated and solidified in a definite sequence in different places. Maybe like veins, pegmatite, like that. Then the second one, how the sedimentary mineralization are going on. There are mainly three methods sedimentary mineralization can be occur. First one is the detrital material derived from the rocks by weathering and erosion. These clastic materials coming through the weathering and erosion process, they are transported and deposited somewhere we want known as a sedimentary mineralization. Then the chemical precipitation of dissolved substances. During the weathering of rocks, some part of that can be solidified with water. They can be moving out. In some basins can be precipitated and then started to the formation of rock type we known as a chemical deposits. As an example, we can go with the limestone. Then other one is vital activity of organism and they are dying off. Maybe in the land area or maybe in the ocean area due to this organism that they are living. However, after that they are dying off and form some type of sediments like chalk deposits are formed like that. We can get an example. Then another one is the metamorphic mineralization. Existing in a rock under the high pressure temperature condition, recrystallization. This is different. It is in the solid states. Earlier in the magmatic mineralization, it started with liquid state and ending with the solid state. And during this metamorphic mineralization and form new minerals and new rocks, this is known as a metamorphic mineralization. Right. Then these mineral deposits, if they concentrated areas, we know as mineral deposits, they can group as a two groups. One is called primary mineral deposits and other one is called secondary mineral deposits. If you're going to the primary mineral deposits, they are formed along with country rock, area rock together. And the sedimentary mineral deposits, secondary mineral deposits, as a result of weathering, erosion and concentration, in later stage they are formed. If you are going to the primary mineral deposits, there are two types, synergate deposits as well as the epigenetic deposits. If you are going with the secondary mineral deposits, again formed with different ways, mechanical concentration, residual concentration, and groundwater process. In the some of the deposits in Sri Lanka, famous deposit in gem mineral deposits, they are alluvial gem deposits under the mechanical concentration. And also like Pulmude mineral sand deposits, like beach mineral placer deposits, this is also mechanical concentration. If you are going to the residual concentration, maybe laterite. The laterite, if it is ferrous rich, we know as a laterite. If it is aluminium rich, we know as a bauxite. Like that. we can classify the mineral deposits. Right. Before going to discuss about minerals in Sri Lanka, mineral deposit or minerals in Sri Lanka, we want to know about briefly geology of Sri Lanka. If you're going to learn about geology of Sri Lanka, 90% of more than 90% of Sri Lanka is composed pre-Cambrian high-grade metamorphic rocks. Then these pre-Cambrian high-grade metamorphic rock terrain in Sri Lanka are divided into 4 parts. It's known as Highland Complex, Vijayan Complex, Wandi Complex, and Kadugannava Complex. These are actually metamorphic rocks. Then in Sri Lanka also we have some few occurrences of igneous rocks, magmatic rocks. But we know in Sri Lanka we don't have any volcanic activities. Therefore, very limited amount of igneous occurrences are present. They are granitic intrusions, dolerite dikes, carbonatites, and vein and pegmatites. These are the few igneous occurrences present in Sri Lankan terrain. Then other one, Jurassic and Miocene sedimentary rocks. I will discuss later what are the Jurassic, Miocene, and Precambrian later. However, in Sri Lanka we have they are formed under the Jurassic and Miocene period. Sedimentary rocks are present in Sri Lankan terrain. And then the quaternary deposits. The quaternary deposit also there are 2 types of quaternary deposit can be going like a tracer deposit like gem gravel and red earth and laterite. These are the example about quaternary deposits. Right. Earlier we discussed about several terms. The Precambrian and Miocene, Jurassic, like that. All the terms are coming with geological time scale. Because we know we are working with geological time scale, the long time scale started with Helian, and now we are mentioning about quaternary period, recent and Pleistocene area are present. According to the geological time scale, we have several economic deposits are formed in Sri Lankan terrain. Therefore, here I mentioned about at the recent, maybe in the 2 parts, maybe in the Pleistocene or recent, there are some economic deposits. Most are industrial mineral like kaolin, ball clay, silica sand, gem gravel, river sand. We mentioned about pulmude, ilmenite, rutile, zircon, monazite. These type of minerals are formed in the recent age. Then the Pleistocene age, we have a gem gravel. Ratnapura beds are there. Then the Miocene time period, there are important economic mineral deposits, limestone, located in from northeastern area like Aruvakkaru, Mana area, we have a sedimentary limestone deposits. And others are pre-Cambrian. Pre-Cambrian is indicated after the Cambrian time period. There are several minerals like dolomite, quartz, feldspar, graphite, apatite, mica, calcite, etc. They are formed in the pre-Cambrian time period. Right. Then again, economic mineral of Sri Lanka can be going as a 2 groups. One is called metallic groups, metals, and other one is called non-metallic group. If you go into the metallic group, again divide to 2 groups, ferrous group and non-ferrous group. The ferrous group are included iron minerals. Hematite, limonite, and magnetite are the ferrous group of mineral. Then non-ferrous group, there are copper deposits, ilmenite, rutile, zircon, some precious metal like gold, silver, we can go as the non-ferrous group. Then the other group, non-metallic groups, there are 2 mainly, industrial mineral and some of the precious and semi-precious stone. If you go to the most of the industrial mineral like mica, carbonate, calcite, dolomite, marble, limestone, chalk, then phosphorus, especially apatite, clay deposits, feldspar, silica sand, vein quartz, carbon like graphite, all are under the industrial mineral. Then the precious gemstone, we are at example like ruby, sapphire are the precious, and semi-precious gemstone maybe a topaz, garnet are the example. Then Sri Lanka is a rich in non-metallic industrial mineral and variety of precious gem minerals. We know Sri Lanka is rich in non-metallic industrial mineral and variety of precious gem mineral. Currently, these are being exploited. Export of few minerals, some as raw materials, and some are in semi-processed form. Others are used only few local mineral industries. Some other industrial mineral used for some local mineral-based industries. Anyway, Sri Lanka cannot be classified as major producer of mineral commodities. Sri Lanka is not major producer of mineral commodities. If you are going with mineral industries of Sri Lanka, you can see other side there is a mineral resource map of Sri Lanka. According to mineral resources are located. Due to that, mineral industries are formed. As example, mineral sand industry are located Ulmati deposit using ilmenite, rutile, circle. The cement industry, Miocene limestone are used for that and located in Puttala. Then fertilizer industry, the Eppavala phosphate deposit we use for the phosphate fertilizer. And dolomite, the magnesium-rich fertilizer used for the deposits in Madre Candy area. Then the graphite industry. We have now Bogle and Kahatakaha graphite mines, but earlier large number of graphite mines are available in Sri Lanka. This historically we are very famous in graphite. And gem mining, it is also very famous industry, especially in the Ratnapura and Nalahara area. Then some industrial mineral like vein quartz, mica, Matale, Kandy, Balangod area, we can see these some. And ceramic and glass industry, they are mainly based in silica sand, calcite, feldspar, and clays. Right. Now we thinking about what are the critical metals. Critical metals. Critical or strategic metals are essential for the development of society and technologies. However, they are vulnerable to the imbalances between supply and demand. If you have a graph like that, supply and risk and economic importance, and the one side we can see what are the critical metals. Here, several critical metals are there. It is including rare earth element also. Therefore, here we can see light rare earth element and heavy rare earth elements both are critical metals. Right. If we go with more detail about critical metals, if you see this table, the rare earth elements are marked here, and the platinum group metals are there, and other minerals also have some critical stage. They are marking according to the USGS 2022 classification. These are the critical metals. Right. Now we consider about the rare earth element. What are the rare earth elements? A group of 17 elements composed of 15 lanthanide, scandium, and yttrium are known as a rare earth element. There are mainly two groups, light rare earth elements and the heavy rare earth element. Right. Then we know about we discuss about rare earth elements. These elements are present as a minerals in the rocks. Therefore, we want to know about rare earth minerals. Up to now, over 2,500 rare earth minerals have been identified today. We can see some of things are in this table, and mostly several rare earth minerals are common. Mentioned about bastonite, loperite, monazite, cenotime, and some of the iron absorption clay minerals. They are normally in the rare earth industry used as a source material. Then why rare earth elements are important? There are several applications. rare earth elements are used across various industries such as electrical, electronic, renewable energy, automotive, medical, and defense industries. Therefore, rare earth elements are very important. If we see the global rare earth demand and supply, there are two figures are there. The one figure is indicated up to the global rare earth oxide demand from 2007 to 2019, and other part is estimated one. The light color part is estimated one. You can see diagram like that. And again, next diagram indicated the global rare earth demand projection up to the 2040. There are two things are concerned. One graph is growing, continuing with historical growth rate. However, we know the world is developing, especially with wind power and electric vehicles. Therefore, rare earth elements are very important strategic mineral. Therefore, the annual growth of rate is maybe expand like that. Up to now, where these type of rare earth elements are located in the global, in the earth, in the world are located. The yellow color are indicated. Now rare earth elements are production sites are indicated. They are like that. Then classification of rare earth resources. The rare earth resources can be classified according to earlier like mineral classification, primary deposit and secondary deposit. In the primary deposits, rare earth elements are associated with carbonatite, alkaline igneous rocks, granite and granitic pegmatite, iron oxide, copper, gold deposit associated. They are known as primary deposits. Other one is the secondary deposits. Secondary deposits are related with weathering, erosion, and transportation material, and again deposited we known as secondary deposit. These are the placer deposits, maybe beach and alluvial, iron absorption weathering crust, laterite, offshore sources, manganese nodules, phosphorites, etc. We can see as a secondary deposit as a rare earth resources. These are some examples about where the rare earth industry is going on. And you can see here several things are associated with carbonatite deposits. Several are associated with carbonatite deposit, and some, the Indian site one is associated with beach places like that. These are the information about existing rare earth industry are going on places in the world. Right, then we want to go with rare earth resources in Sri Lanka. Sri Lanka has a geological setting that are favorable for the formation of rare earth resources. The monazite containing cerium was the first rare earth mineral detected in Sri Lanka. It was found in gem gravels during a mineral survey in 1914 identified. The monazite containing cerium is the first rare earth element found in Sri Lanka. Then after that also several things are going on study about rare earth element. Here mentioned about a few geochemical studies have reported considerable concentration of rare earth element in different geological formation in Sierra Atoll 1987, 1991, 203, 214, like that. Several studies are going on. And this data can be seen in like a table here, where the rare earth potential of Sri Lanka. However, there have been no significant attempts to explore the geological formation in detail to find rare earth prospect as well as the recovery potential. Therefore, there is a gap is identified. Our research team initiated detailed investigation to assess the potential of rare earth element in Sri Lanka, their economic significance and recovery potential under the DOR project. Started with 2009. If you are going with the detail about our rare earth element project, the Professor Nalin Ratnayak is the principal investigation, and the some of the members are in our department, and we are get 2 research assistants, and one is researchers for the PhD student, and other one is the MPhil student. The project is initiated in March 2019, and project period is 3 years. In the main item in this project is ICP-MS instrument. Why ICP-MS instrument for import for this project? In the rare earth elements are present as part per billion. We don't have a facilities for identification that level. We cannot study with the rare earth element. Therefore, rare earth element studies started together with the ICP-MS instrument, purchasing, install, and commencement of unit. Now it is in the analytical lab of the Earth Resource Engineering Department, University of Moratuwa are located. Actually, the grant is 40 million. The instrument is 35 million. The important one is this instrument for that project. And I also want to know about our research assistant also. Now the project is complete. We will discuss later. One of the research assistant, Nadira Batakola, she is completed MPhil, and this year she is graduated. This year convocation graduated, and the engineer Dushyant is a PhD student. Now he submitted his thesis, and maybe within few months his presentation you can get a more knowledge about, especially for extraction of rare earth elements. Actually, these are do good work in this project. Therefore, they get the several chances. Actually, Mr. Dushyant get the opportunity to join with the Uwe University as a lecturer, and also Nadira Bhattapala. Now she is working with our department as a temporary lecturer. The project, they give this type of opportunities also for our research assistants. Right. The main objective of our project is to assess the real potential in different geological formation of Sri Lanka based on their origin and occurrences and development of extraction techniques. There are specific objectives to analyze rare earth concentration in selected geological formation, to characterize the enrichment and distribution of rare earth element in different types of geological formations, to identify most prospective rare earth source or sources in Sri Lanka, and to assess their economic significance and recovery potential in terms of rare earth elements. Then, area of exploration and sample collection. Then we identified 3 areas, mainly three different geological formations are more potential for this type of rare earth element. One is the residual lateritic regolith, second one is the placer deposits, and third one is the magmatic occurrences. We are collected, rock, soil, and sediment samples are collected. If we simply go, the sample preparation methods are like that. If you are going the three type of sample, rock sample, soil sample, and sediment samples. And we prepared sample according to this way and used for the ICP-MS analysis. Then we take from prepared sample and then go with the aqua regia digestion and dilute it and go for the rare earth ICP-MS analysis. For this analysis, we are going with using standard solutions as well as the quality control of the analysis. Very important in this type of work. We are working with part per billion size per billion. Therefore, we are going according to these procedures. Right. Then the residual lateritic regolith, we identify 2 locations. One is carbonatite associated one, and other one is serpentinite associated regolith. Carbonatite associated regolith are located in Ekpavala. It is already all of you know about Ekpavala phosphate deposit. It is carbonatite associated regolith we use for our study. Other one is the Gidigal Palace serpentinite deposit. and if both are in origin is magmatic origin. Their host rocks are related with magmatic activities, carbonatite, apatite, as well as the serpentinite in critical colors. All are related like that. Then the sample collection in Epaulo phosphate deposits. In the Epaulo deposit, we have apatite crystals and secondary matrix. And also carbonatite rock sample, host rock. We get sample about all the three kind of sample. Apatite crystals as a primary crystal and secondary matrix. And the third one, carbonate rock sample, carbonatite rock sample, host rock sample. And we get this sample for Epaulo phosphate deposits. And the clinical serpentinite deposits also gets several rock and soil samples like that, 13 soil rock sample and 19 soil sample for analyze for that purpose. And what are the things we can come in with this one? The secondary weathering profile of Epaulo phosphate deposit highly enriched with rare earth elements. We get the average value like 4,072 milligram per kilogram, and secondary phosphate, the matrix one, it is also close to that value like 4,063 milligram per kilogram are identified in the Epaulo phosphate deposits. Then what are the type of rare earth elements present in the Epaulo phosphate? Here mentioned about lanthanum, cerium, parasomidium, neodymium, europium, polonium, and terbium and yttrium. These are the we can see in the Epaulo phosphate deposit. Then if you are going to the serpentinite deposit, it is also magmatic origin. However, they are show very low about rare earth elements. However, it is therefore we can say like that the rare earth enrichment in residual lateritic deposit is mainly governed by the presence of rare earth enriched host rock. In the Epaulo one, host rock is carbonatite apatite rock, and the vinegar palazzo one, it is a serpentinite rock. Therefore, according to that, these residual lateritic regolith, we can get idea about they are highly enriched in rare earth elements can be seen in the Epaulo deposits. Right. As a second selection, placer deposits. There are two types of placers, beach placers and alluvial placers. In the beach placers, we get the northeast coast, the Pulmude deposit, as well as the little below vertical deposits. We get sample from these two deposits. And the southwest area started with Panathura to Gold area. We are sampling for beach placers. And then alluvial placers. They are transported through the rivers. We select the Walaway River Basin. Why we select the Walaway River Basin? Walaway River Basin, historically we know there are gold are present. If the gold are present, there is some possibility about rare earth elements also can be present with these pegmatites, veins, pegmatite associated rock, associated metamorphic rock environment. Therefore, we select the Walaway River Basin for that. Then the Pulmude area, we get the number of samples. 26 samples are collected in this area and analysis for the rare earth potential. And the vertical deposits also taking samples for that one, and 18 samples are collected in this area for the rare earth analysis. And if you go to the southern part, southwest coast, also taking 18 samples for that one and analyze for the rare earth element concentration. Then alluvial place, we mentioned that we select the Walaway River Basin. We know the Walaway River Basin is related with Samalava project. Therefore, we know there is some effect with dams in that one. Therefore, we selected the upstream of the dam as well as the downstream of the dam also collected some samples, Walawe River basin. And also in the upstream, more further, there are going with Kirikati oil and Beluhulo like areas. Also, we get a sample from that location and going with analysis of rare earth potential. Then, if you go to the beach places, our results are like that. Compared to the Verugal and southwest coast, the Kolmude deposits have shown higher value rare earth potential are there. And if you are going with the alluvial places, here we can see some medium enrichment of rare earth elements can be seen in this area. However, the values are same like that, while the similar catchment level suggests that they have been derived from the same source rock in the catchment of the Walawe River basin that constitute granitic pegmatic occurrences are there. Due to that, these sediments are may be present with these rare earth elements. Right. Then, lastly, third one, we are going with the magmatic occurrences. We selected granite and pegmatites. Granite are igneous rocks. We are going with the several igneous rocks present in Sri Lanka's Thonigala, Massanna, Arangala, and Abeysinghe areas. Actually, some say like that these are not completely igneous rock, maybe igneous looking rock. Anyway, the Arangala and Massanna are more related to the igneous origin like that. And we take sample from these granites. And we get the pegmatite sample, we get the one location, Rattota Matale, you know, these are the famous location in Feldspar mine used for the ceramic industry, for the Noritake factory. This largest feldspar deposit located in Rattota Matale area, we take sample from this pegmatite for our rare earth element analysis. From the Thonigala granite, we get the several samples. Here mentioned that 17 rock samples are collected in the Thonigala granite. And the Massanna granite, we taken, it is also known as a zircon granite. Massanna zircon granite. It is very famous for zircon are present with this granite. Then we get the 10 rock sample collected from this Massanna granite area. And the Arangala granite, also we take 6 rock sample. It is not large outcrop. It is a small outcrop close to the beach area. We get the 6 rock sample for analysis. And the Abeysinghe granite, located in Gampha district, we get 6 rock sample for analysis for the Abeysinghe granite. Then the Rattota pegmatite granite, we take several 6 rock sample for selected for the Rattota pegmatite for our analysis. We will see what are the results we are taken after the rare earth element analysis. Rare earth elements are enriched in Massanna and Arangala granite. Comparatively, it is high, but it is not like Pulmude or not like Eppaval area. It is some rich are present, but not like that. This information about the granite. Then if you are going with the summary and our main idea, potential of rare earth prospect in Sri Lanka. If you are getting the deposit type, deposit name, as well as the total rare earth element content and enriched rare earth elements like that. If you are going with the Eppaval phosphate deposit, this is a carbonatite deposit, and we have a higher value of total rare earth content identified here in the Eppaval phosphate one. Serpentinite, we mentioned that is a very low amount are present. Then if you are going to the beach places, the beach and alluvial places, placer deposits, the Pulmude deposits are indicated there are high potential for the rare earth element. We know maybe related with the monazite mineral in the Pulmude deposit. We know they are common in the monazite. It may be rich in pulmonary deposits, we can identify as a potential source for the rare earth element. Then, if you are going with the alluvial plains, they are not indicated much rare earth elements are present. Then, if you are going to granite, the most igneous granite like Arangala and Massanite, not igneous looking like Arangala and Massanite are indicated little higher rare earth element percentage are there. However, the Rathota one indicated less amount of one. It may be due to these pegmatites. Mainly, they are vein types are also there. Quartz and feldspar are separately present like that. Therefore, maybe a reason for the rare earth elements are less. It's like a vein deposits. Then, if you are going with the epaulphosphate deposit as a source of rare earth element, it is already identified. It's a highly enriched with total rare earth elements. And what are the rare earth elements present in there? And some of the rare earth elements can be used for the renewable energy technologies like that. And the average rare earth oxide rate are calculated, indicated total rare earth oxide is 0.48. However, the cutoff grade of the rare earth oxide grade is 1.5 in the world. Now we are thinking about the cutoff grade of the rare earth oxide is 1.5. But has a sufficient rare earth potential to extract them as a byproduct during the going on with fertilizer industry may have a good potential are there in these deposits. Then now, the epaulphosphate deposits are used for the fertilizer industry. We will know the epaulphosphate deposit, only economic phosphate deposit in Sri Lanka with 60 million tons of reserve are calculated are present. Currently produced phosphate fertilizers, there are two types, high-grade epaulphosphate and the epaulphosphate. There are two types of things are going on rock phosphate as a rock phosphate. The rock phosphate commonly used for the long-term crops. Why? Due to the low solubility of this material. Right. Then our team is identified. There is a high potential of rare earth elements related with epaulphosphate deposit and surrounding area. Therefore, studies are going on. Take a rare earth elements extraction using these two types of fertilizer production like that in the power deposit have crystals as well as the matrix. From that, how we take and rare earth element. The other one is check with the area, surrounding area. Here mentioned that lake sediments. That means we know in the weathering process, the phosphate deposit, there are some rare earth elements can be transported and deposited in this together with this lake sediment. Therefore, studies are continue with lake sediments and indicated that there is a potential of rare earth elements and compare with the taken with rare earth element extraction from crystals or matrix. If you are going with the lake sediments, it's little easier. However, if we identify require for this purpose require sustainable process to recover rare earth elements available in the epaulphosphate deposit while producing the phosphate fertilizers. We want to take this rare earth element while producing the phosphate fertilizers. Therefore, this purpose, the research is going on, select the good type of lixiviant. There are several lixiviants are tested with our laboratories and identify the most efficient one is the hydrochloric acid. However, we know if it is hydrochloric acid together with this phosphate, then we can use as a phosphate fertilizer. Therefore, the second most effective phosphoric acid is recommended for the lixiviant for the decay potential. And the final target of this rare earth production from the Ekpal phosphate deposits can be seen in this diagram. And we taken from the high Ekpal rock phosphate and Ekpal rock phosphate both together and finding a leachate. Up to now, the leachate is finding. Then the research is most probably is completed. I will not discuss in more in here. Why? Our PhD student, Mr. Dushanta, he is do this one, and the thesis also submitted. In very near future, within 1-2 months, you can see a public presentation how we can take rare earth site from the existing Ekpal phosphate deposits. And if we are going with this, we can go with the one is the liquid phosphate fertilizer and other one is the rare earth oxide. Therefore, there are two types of industry can be developed: liquid phosphate fertilizer industry as well as the rare earth industry of Sri Lanka. And the liquid phosphate is very important compared with the existing rock phosphate. Existing rock phosphate solubility is less. However, liquid phosphate solubility is high. We can use for the not only the long-term crops, we can use for the short-term crops also. Right. I am coming with the finally concluding remarks. In this present study, the Ekpal phosphate deposit was identified as the most prospective rare sources in Sri Lanka, considering its economic potential to extract rare earth elements as a byproduct from the phosphate production flow. Moreover, the Ekpal phosphate is enriched with critical rare earth elements. We discussed about name like that, further highlighting its economic potential, and we can say it's a viable rare source of Sri Lanka. The average rare oxide grade is about 0.48, with estimated resource potential is 0.9 million tons of rare earth oxide. Although the rare oxide grade in the Ekpal phosphate deposit is less than the global cutoff grade 1.5, the EPD could become a potential secondary rare earth resources considering the rapid outstripping demand of rare earth element over the limited supply. Therefore, the up to now cutoff grade is 1.5. However, we can go with due to this critical metal or rare earth element. Therefore, we have a very good chance for the Ekpal phosphate deposit be used for the rare earth one. Therefore, with the developed and upgraded of extraction techniques, the Ekpal phosphate deposit could become a potential diverse source of rare earth elements that may open a new dimension of Sri Lanka mineral industry. And finally, I like to acknowledge for the HEAD project. The project is started in March 2009. The project time period is 3 years. We get the extension due to the COVID situation 6 months, and the project is successfully completed. Middle of 2023, project is successfully completed. And the DOR head projects mainly going with the publication. I am not going with total publication. Here we inform about some important journal, index journal publication. Most are Q1 and Q2 journals. We have a possibility to publish these publications. And finally, if anyone is interested, we give us some information about this project in the research magazine of the University of Moratuwa, we commonly known Golgotha Plains. In the volume 2, issue 1, in September 22, you can see a topic like exploration for rare earth elements in different geological formation of Sri Lanka and recovery potential. You can read out this one. Thank you for all.
Thank you, Professor. Insightful lecture and the knowledge and expertise you shared with us. So, may I invite the Dean, the Faculty of Graduate Studies, Professor Ruan Gopura, to hand over the token of appreciation to our professor. Ladies and gentlemen, as we draw this event to a close, We would like to extend our heartfelt gratitude to you for your presence and engagement. So, we warmly invite you to be part of our next inaugural session in February. Thank you.